Alright guys, so list all the factors of each number, then find the greatest common factor. So what are all the factors of 4?
1, 4.
1, 2, 4. Yep.
Yeah.
What about 18?
1, 2, 9, 3,
Mm-hmm.
3, 6, 9.
Yep. So all the numbers that divide in evenly. And then what is the biggest number that they have in common? 2. Yep. So 2 would be the GCF. Good? Yes? Okay, so perform the indicated operation. Number 2, we are multiplying. Do we remember what to do with exponents when we're doing multiplication? Add them. Yep. So you do 3 times 4, which is what? 12, and then x to the add the exponents. 7th. Yep. And then do we remember what to do with exponents when we divide? Subtract. Yep. So you'll divide the 14 and the 2 to make what? 7y to the 4th. Yep. Any questions on that? Okay. So, your objective today, students will be able to multiply a monomial. What's monomial mean? Yep, one-term polynomial. Perfect. By a polynomial. And that's just going to be all polynomials. And factor a monomial from a polynomial. So we've done multiplication with exponent rules and stuff before. I think we did distributive property a little bit on like in unit 7, but we're just gonna do like one problem of distributive property, just kind of like refresh if anything, and just start the multiplication process. And then the next lesson we're gonna continue with multiplication. Okay, but our main focus is gonna be that factoring. So what is the simplified form of negative x to the 3rd times all that? So what number is actually in front of that x to the 3rd? Yep, a 1. So this is like negative 1 x to the 3rd. Just for the purposes of like multiplying things. So we're going to distribute that. And remember, when we're multiplying, what do we do with exponents? Add them. Yep, so we're going to do negative 1x to the 3rd times 9x to the 4th. And what's that going to be? Negative 9x to the 7th. Do you remember add exponents? Okay, then negative 1x to the 3rd times negative 2x to the 3rd. Yep, positive 2x to the 6th. Does that make sense?
Yeah.
Okay. Yeah. And then negative 1x to the 3rd times 7. Mm-hmm. So does the 7 have an x at all? Yep, so just say it's 3rd. If that was 7x, then it would be to the 4th, because that would be an x to the 1st power. Okay? Are we good on that? Okay, try the next one. Yeah. Next week, Friday.
It's the only quiz going in.
Unit 9 is the end of term 3 for this class.
Oh, okay.
Yeah, so after that test, it's great stuff. And then Unit 10 is going to go in for the next quarter.
So whatever like you get on that test, once you put it in, it's like basically
Yeah.
no grade.
Pretty much, yeah.
Have you put it? Oh, no.
I have not.
Please don't make me fail.
Okay, guys, do get this one. Okay, ready? Okay.
I'm sorry.
Are we ready or not yet? Okay. Okay, got another few seconds. Okay, so this is 5n to the what power? First. Yep, so when you 5n times 3n to the third, what do you get? 15n to the fourth, yep. Okay, 5n times negative n squared. Yep, negative 5n to the third. And 5n times 8. Yep. Okay, does that make sense to everybody? Do you have any questions on that? Charlie? Yes.
Should I put like the 1?
If you want to, yeah. Mm-hmm. Yeah. So that's just like the kind of like basic multiplication. We're going to do like the more complicated ones in a separate lesson. But the next part and like the main focus is all about the greatest common factor and factoring it out. So the second half of this unit is something called factoring. And that's basically when we take a polynomial like this and we like break it into all of the different individual little parts that multiplied to make that polynomial, okay? So one of the chunks would be like this 5n for this one would be like a part that multiplied in to make that answer, right? So the GCF part, factoring it out, is just breaking that first chunk off and trying to like undo the distributive property and take back out what was distributed into everything, right? So first we're just going to focus on finding the GCF, and then I'll show you how to like actually factor it out. So for the GCF, you are going to find the greatest common factor of the numbers, like of the coefficients, the numbers in front of the x. And then for the variables, your GCF is always going to contain the lowest quantity of variables that you have. And I'll explain why in a second. Okay, so can I have three volunteers? And just stand up here real quick. This helped second hour a lot, so they said to do it with every class. Okay. So if I'm looking at this problem right here. So come over here real quick, guys. So the first person in the row, so Larry, come here, you're going to have 4 pens, okay? So then you go stand in that first spot over there, on that side, yeah. And then Rio, come here, you're going to have 2 pens. Avery, you're going to have 1 pen, okay? So then those are going to be the exponents. If we look at the last problem we just did, 15n to the 4th minus 5n to the 3rd plus 40n. So we have 4 pens, 3 pens, and 1 pen. Yes, good? Olivia, put it away. Thank you. Oh, just kidding. Here's another one, sorry.
Yeah.
Sure. Okay, so you have 4, 3, and 1.
Thank you.
Okay, so if I'm going to take pens away from all of them, and I'm going to take the same number of pens away from each of them, what is the most amount of pens I could take? 1. Why? Mm-hmm. And then, so she's just going to go negative, right? So the most I can take away from each of them is only 1 pen, because then she's going to be left with 0 and doesn't have any more to give than 1. Does that make sense? Yes? Okay. So whenever you're doing the GCF, you're always going to use the smallest exponent that you have for the variable, because otherwise that person won't have enough to give if you try to take more away, okay? So think about that when we get to GCF for here. So whenever you are doing GCF, after you already have your answer, for the numbers, you're trying to find the biggest number they're all divisible by. So I have 5, I have 25, and I have 45. One way that you could do this is you could do like a factor tree. So you could break this into like 1 and 5. This would be 5 and 5. And then 45 would be 5 and 9, and then 3 and 3. So then figure out what do they have in common. Yep, they all have a single 5 in common, right? Yes? So that would be your GCF. Or instead of doing that, you could just think, what's the biggest number that I can divide 5, 25, and 45 all by? 5, right? Make sense? Okay, so 5 is going to be the first part of your GCF. And then for the x's, it's always going to be the smallest amount, whoever has the least amount of pens, right? So what's that going to be? If I have 3, 2, and 1. I can only take 1, right? So your GCF is going to be 5x. 5x to the second power, yeah. The lowest amount of the exponent variable, yeah. Yeah, yeah. All Okay, so go ahead and just try to figure out what the GCF is of the next one. Do we think we got it? Okay, so what did you guys get for the GCF for this one? 3x. Yep. Because they all have at least a single x, and then 3 is the biggest number they're all divisible by. Does that make sense, guys? Hello, hi. Does this make sense? 3x? Okay. I know it's not 3. Okay. Okay, good. All right, same thing on this one. So 40x squared minus 16. What do we think? 8? Huh? Well, it's the biggest number they're all divisible by. Yep, 8. Mm-hmm. So the way that you would do this with factories, if you did 40 and 16, 4, you could break into 4 and 10, and this is 2 and 2, 5 and 2. You stop when you get prime numbers. So I'll show you. Yeah, how you get to that. So 16, you would do 4 and 4, 2 and 2, 2 and 2. So what do they have in common? How many?
6. Oh, 1, 6, 7.
So they each have 3 2s in common, right? Do we agree?
Yeah.
Okay, so then you would do 2 times 2 times 2, which is what? Mm-hmm. Yeah. Yeah. Oh, it's a longer way, yeah. But if you're in a bind and you're not sure if it's like the biggest number or whatever, you could always break it down to all prime numbers and then multiply whatever they have in common together. Okay? So it's gonna be 8, and then what about for the variables? So this one has 2 x's. How many does this one have? 0, right? There's not even an x. So can I take any away from them? Nope, so it's just 8. Okay. And then you guys do the next one. Okay, we done? Okay. Okay, what did you guys get for this one? GCF equals 7x squared? Did everyone get that?
Yes.
So it's because this one has 3 and this one has 2. So you could take 2 away from both of them. So it's whatever the smallest x one is. Okay? All right, so now that we know how to find the GCF, now we're going to practice factoring out the GCF. So I need you guys to think about this as basically, like, this is literally the reverse of distributive property. So you're thinking about it as someone distributed something in, and now we're having to go in and, like, pull it back out. Okay? So essentially we're dividing, which means we do what with exponents? If we're dividing. Subtract. Yep. Okay, so we're looking at this. What is the factored form of 4x to the 5th minus 24x to the 3rd plus 8x? So first we need to figure out what our GCF actually is. 4? 4, just 4? 4x, yep. Because they all have at least a single x. Agreed? Yes? Any questions on that? Okay, so what you're going to do is you're going to like undistribute the 4x now. So put 4x in front of the parentheses. And you're going to have to divide it back out of each of the terms. So what's 4x to the 5th divided by 4x to just 4x? X to the 4th. Yep, so you're subtracting exponents because when you multiply that in, you added it. No, you just divide. 4 divided by 4 is 1. Yeah. So here, and then double check. If I multiply 4x times x to the 4th, is that going to give me 4x to the 5th? Yes. So you know that you did it right. Okay? So next, negative 24x to the 3rd divided by 4x. So is it plus or minus 6? Yeah, minus 6x to the what? Yep, 3 minus 1 is 2. And then what about 8x times 4x? Or no, sorry, 8x divided by 4x, sorry. Yep, so 8 divided by 4 is 2. And then x, you took the whole x away, so there's no x's left in the last one. So that whole thing is your answer. So pay attention on Math Excel. If it says find the GCF, you would just say 4x. If it said factor out the GCF, that's when you do the whole thing and actually pull it back out. So if you did this correctly with the variables and stuff, this last thing that you have should never have any variables whatsoever. Okay? All right, go ahead and try the next one. Okay, we good? Or do you need more time? More time? Okay. Let's see. Can we go now? Okay. All right, so what did you guys say was the GCF of this? 3x squared. Okay, so you're going to put the 3x squared out front. So it's 9x to the 6th divided by 3x squared. Yep, 3x to the 4th. Wait, what about 15x to the 4th divided by 3x squared? Yeah, 5x squared. Because you're taking 2 away from each of them when you divide. Because then when you multiply that in, that's they got added. Yep, and then plus 4. That's it. Any questions there? This is like a super important skill. Like this is the first step for every single day next, like the end of this unit. 10-4 to 10-7, you start with this every single day. Okay? Every problem. So it's really important. Okay, we're going to do the lesson check real quick. Then you guys have math Excels if you finish the lesson check also, remember. Yeah. Are you guys done with the warm up? Okay. Second. All right, guys. What do you get when you distribute that 6x?
12x
Yep. Okay, what number 2?
GCF is 2a squared.
Yep, 2a squared. Okay, and then factoring. So what's my GCF of number 3? 3m. Yep, and then what's left on the inside?
2m minus 5.
Yep. That's it. Okay, and then the last one, what's the GCF?
4x.
4x. So what's left on the inside?
X squared plus 4x
Mm.
plus 2.
2x. It's a simple mistake. Yeah, because of joining. Okay, we good?
What?